Hello, lovely people. Welcome to a question where we are looking at integration using the powerful technique of substitution. And it says here, using the substitution, u squared equals 2x minus 1, or otherwise find the exact value of this integral here. Now, if they're telling us to use substitution, we should probably use the method that they tell us. It's easier, we don't have to think about too much, we just go and do the process. So, as per usual, you've got that u squared is equal to 2x minus 1. What we're going to end up doing at some stage is differentiating. So we want to work out what du dx is in some way, shape or form. Now, if we were to differentiate both sides with respect to x, we apply some implicit differentiation. So the left-hand side will differentiate to 2u du dx, just applying that implicit differentiation, and that is equal to, well, 2x minus 1 differentiated with respect to x is just 2. Okay, lovely stuff. Now we have 2u du equals 2 dx, treating the du dx like a fraction. We can also cancel down the 2, so we're just left with u du equals dx. Okay, so we can start to substitute a few things here. Yeah, let's do that actually. What we can also do is we realize that we still have this 3x that we're going to have to deal with at some stage. So we can go ahead and we can deal with that as well. So we can rearrange this to make x the subject. So that means that u squared plus 1 all divided by 2 is going to equal x. Now we can go ahead and make a few changes. So this becomes the integral of 3 lots of x, but x was equal to u squared plus 1 all over 2. And then that's all divided by the square root of, well, 2x minus 1 was equal to u squared. And dx was equal to u du, so times by u du. Now, there's another thing that we need to do. We need to also change the limits. So we could integrate, change back to x, and use the limits of 5 and 1, but we can actually change the limits now. So we know that u squared equals 2x minus 1. So if we substitute the lower limit for x, so x equals 1, we get u squared equals 2 times 1 minus 1. So u squared is equal to 2 minus 1, which is 1. Then if we also sub x equals 5, the other limit, we get that u squared equals 2 lots of 5 minus 1. So u squared equals 9. Therefore, u is going to equal 3. Now, we use 3 and not minus 3 because this limit is bigger than the other limit, essentially. So our new limits become 1 and 3 at the top, like that. Now what we need to do is just simplify our integrand. The integrand is basically just the bit that's here, fancy way of saying that. So we integrate between u equals 1 and u equals 3. Well, let's simplify a few little things. So we can actually take out the 3 and we can take out this 2 as well. So that's basically 3 over 2 out here. And then we're left with u squared plus 1 over, well, the square root of u squared is just u, times that by u du. So these this simplification bit usually trips people, so just make sure that you're very careful on that particular part when you're carrying out these integrations. So that's 3 over 2 lots of, from u equals 1 to u equals 3, u squared plus 1, the u here and here will cancel, so you're actually just left with u squared plus 1 du. Now it's a nice simple integral that we can perform. So that's 3 over 2 bracket. So the u squared integrates to u cubed over 3, and the 1 integrates to u. And we, of course, have the u equals 1, u equals 3. Okay, and then when we substitute that in, so we get 3 over 2 lots of, so substitute the 3 in, we get 3 cubed over 3 plus 3. So there's that bit substituted. And then we take away the lower limit, which is 1 cubed over 3 plus 1, giving us 3 over 2. And then, so 3 cubed divided by 3 is just 3 squared, which is 9. So we have 9 plus 3. Take away a third plus 1. So that's going to be a third plus 1. Then we have 3 over 2. Lots of, so 9 plus 3 is 12. Minus a third plus 1, well, that's equal to 4 thirds. And then 3 over 2, well, 12 is the same thing as 36 over 3. So 36 over 3, take away 4 over 3, giving us 3 over 2, lots of 32 over 3. So we times those things out and we get 16. So that's our exact value. That's what we're looking for. So hopefully this question demonstrates just the steps that we go through for integration by substitution. Take care.